Hello YouTube, this is our fourth video. In this video, we desire to explain why we perform certain steps in solving a canonical long division problem. We will perform a division within a placeholder of a sample problem using the method of division by placeholder units. The goal of this sample division will be to demonstrate the logic of this division process. There are two quick issues that we need to address before we examine our sample problem. The first issue is the type of division method that we shall use. Generically, in American schools, they teach us two methods of division. One method is called division by value, and the second method is division by placeholder units. Simply put, division by value attempts to divide based upon the whole value of the number we divide, the dividend. In contrast, division by placeholder units ignores the whole value of a particular placeholder. It instead focuses upon the number of units contained in a placeholder. The division obtains a subquotient or answer based upon this quantity of units, not their value. The second issue is the format and method of division that we will utilize. We should utilize what I call a canonical or traditional form of long division. There are newer similar forms and methods of long division, but we are referring to the long division method and format generally taught in the 1980s, 1970s, and previous decades. We will examine division by placeholder units because it is the most commonly taught and used method and format. Division by placeholder units, although exceedingly simple to understand and to perform, generally is taught exceptionally poorly in American schools. There are three ideas, concepts, processes in division by placeholder units. One, determine the maximum single integer number of divisors, better known as the subquotient, contained in a placeholder's units. Two, determine the difference between the quantity of placeholder units, better known as the subdividend, and the product of the subquotient and the divisor. Three, transfer the difference between the subdividend and the product of the subquotient and the divisor to the next lower and adjacent placeholder. We perform these three processes in a placeholder in order to accomplish a singular goal. Our goal is to obtain the maximum single digit integer subquotient for all the placeholders. If you understand this singular goal, then you likely will understand this format and method of division. Our sample problem is 18,848 divided by 32. We will concentrate our efforts upon the 100th placeholder since it is the first placeholder to have a non-zero subquotient. Performing canonical long division using the method of division by placeholder units gives us 188 units of 100 in the 100th placeholder. Our first process is to determine the maximum single digit number of integer divisors in 188 units, our subdividend. We determine that this number equals 5. The number 5 is our subquotient. We have achieved our goal for this placeholder, which also is a singular goal for long division using division by placeholder units. Determine the maximum single digit integer subquotient for the placeholder. However, we need to perform the other two processes for administrative purposes. The second process is to subtract from our quantity of placeholder units, our subdividend, the product of the subquotient and the divisor. There are various related interpretations for this process. However, we simply will state that the goal of this process is to determine the part of the subdividend that is evenly divisible by the divisor and to determine the part of the subdividend that is not evenly divisible by the divisor. In our 100th placeholder example, the product of the subquotient and the divisor is 160, or 5 times 32. The value 160 tells us that the part, number of units, of the subdividend 188 that is evenly divisible by the divisor. The difference between 188 and 160 tells us the part, number of units, of the subdividend that is not evenly divisible by the divisor. At this point, it may not be obvious why we perform this process, but the third process should make it clearer to see and to understand why. Our third process is to transfer the difference between the subdividend, 188, and our product of the subquotient, 5, and the divisor, 32. The difference between 188 and 160 is 28. In order to transfer this difference to the next lower and adjacent placeholder, the tens placeholder, we need to make this 28 units of 100 equal or equivalent to the units or the number of units in the 10 placeholder. We do this by multiplying the 28 by 10, and we obtain a value of 280 units of 10. We send these 280 units of 10 to the tens placeholder, and we add the 280 units of 10 to the existing units of 10 in the placeholder. This existing quantity of units is 4 units of 10. Our sum equals 284, or 280 plus 4 units of 10. The reason why we transferred the 28 units of 100 to the tens placeholder is because we desire a maximum single digit subquotient for our placeholders. Since the 28 units of 100 in our original 188 units of 100 is not evenly divisible by our divisor 32, the 28 units of 100 does not give an integer subquotient. That is why we transfer this difference to the next and lower placeholder. Understand? In our canonical long division by placeholder units, we typically find our difference and then we use an arrow to bring down our next digit. This gives us our new subdividend. This process of using arrows to indicate our new subdividend is equal or equivalent to the two processes that we performed in this paragraph and the previous 3 paragraphs. Do you see how the two processes, the second and third, are equal to the process performed in canonical long division by placeholder units? If it is not clear, then please review the second and third processes in this video. Look at the values on the whiteboard, and if you have not done so, activate the closed captions for this video. I hope this walkthrough helps the learner to understand canonical long division by placeholder units. If it has not, then please ask any relevant questions in the comments section. If you go to the website at the top of our whiteboard, arithmetichelp.com, we offer an ebook. Additionally, we also offer a free sample download of our ebook. This free sample download contains approximately 75 pages and 60 pages of instruction. Thank you for your time. Have a great day, YouTube.